Hello, once again. Let's try this again. I'm so sorry for all the technological difficulties. Hello, and welcome to the Daily Space for today, Thursday, September 5th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. And right now, you are really grateful you're on the other side of the internet from me because I have a really bad head cold and it's making everything a little bit slower and harder to do. But the show must go on. And I'm going to actually be doing a clean reading of, notes that I'm still in the process of writing to start creating a podcast version of this show. If you're like me, you listen to audio while you're wandering around your house, getting things done, while you're walking around the office, getting things done. And basically, podcasts are that fuel that prevents my brain from reminding me, hey, you could be doing this thing that you're not supposed to be doing right now that's way more interesting than what you're doing. I can just feed that easily bored part of my brain to an audio file and keep going with my day-to-day tasks. If you, too, are a podcast listener for whatever reason, stay tuned because the Daily Space will be coming to a podcast outlet near you later today. But for now, we are here for you here on twitch.tv, and we will stay here always for you here on twitch.tv. In today's news, we have a whole variety of different stories coming to us from pretty much all parts of our universe. And our first story comes to us, and I'm looking up the distance to this object, and I don't have it written down. Our first story comes to us from a not too distant galaxy and from the space observatory NuSTAR. Launched back in 2012, this particular instrument covers an area of the X-ray spectrum that we hadn't previously been able to reach with the Chandra X-Ray observatory. And with its observations, we're able to do new kinds of follow-up on supernova gamma ray bursts, mergers, and other high-energy events throughout our universe. Recently, NuSTAR was doing follow-up of a supernova event, which is the bluish-green dots in the upper part of this particular galaxy. And at some point between the first set of observations and the second set of observations, something new and interesting happened down near the core of this galaxy. And it's thought that this might be some kind of a compact object merger. Now, what's particularly cool about results like this is we didn't catch the initial cause of this, X-ray illumination. And it's only because of the serendipity of observing this field for other kinds of objects that this discovery was able to be made. Now, this is the fourth ultra-luminous X-ray source to be spotted in this particular galaxy. And we don't have a lot of details, but I can't see what that happy noise was for because technological flail. So thank you for whatever that was. We can't see down into the core of this galaxy to find out exactly what all is going on that's causing all of these amazing ultraluminous X-ray sources to go off in this system. But because we now know to look, because NuSTAR is out there doing the looking for us, we're becoming more and more aware of this new class of high-energy objects. Okay, so in our next story, we have a case of theoretical predictions finally having their observational day in the sun. About 20 years ago, it was predicted that hot Jupiters, which are planets a lot like Jupiter, but that are snuggled up against their host star in orbits that are often smaller than the orbits of Mercury. It was predicted that these particular kinds of gas giants should have in their atmosphere both sodium and potassium. These two fairly common elements, at these kinds of temperatures are vapors. And In looking for these particular gases, we'd been finding the sodium for years, but the potassium, well, has thus far eluded observation. In new observations coming to us from the Large Binocular Telescope, which is a combination of two separate 8.4-meter telescopes working together. I'm sorry, I'm going to cough. I will live. I will live. I'm going to grab my coffee. My coffee is empty. It's that day, people. It's that day. Anyways, going back to the story. It was predicted that with their temperature of a few thousand degrees Kelvin, these hot Jupiters should have that. Gonna make it. Should have vaporized potassium and sodium in their atmospheres. We hadn't found the potassium until now, using, as I said, that combination of two 8.4-meter mirrors. Astronomers were finally able to tease out of observations those narrow potassium lines, or not so much narrow as those not very visible potassium lines. The way this works is when the planet passes in front of its host star, we can see the gases that are in the planet's atmosphere absorbing out key colors of light from the star's sunlight. When we do this, we have a problem, though, of we have all the light from the star, and we see its various lines. Then we have the very small impact of the planetary atmosphere's absorption of that starlight on top of the star's light. So we have to subtract out everything that we know is coming from the star to get at what's left, which is coming from the planet. This isn't easy. And this particular star, HD 189733, and its planet, which is all those same letters and numbers, followed by a B, is the most observed combination of star and planet. This particular system is only 64 light years away. The planet orbits every 53 hours, and its orbit is 1/30th the size of the Earth's orbit around the sun. And now, finally, having used this massive telescopic system, that long ago predicted potassium has been proven to be there, showing that at least when it comes to modeling planetary atmospheres, we know what we're doing. So it's not the most exciting of science, unless, of course, you're that theorist. But this is a key result helping us know that what we're doing is on the right track. Now, today is a busy day in planetary news, especially exoplanetary news. And thank you so much for whatever happy thing just occurred. Again, it's over there. I can't see it from over here. My iPad batteries died. It's that day. Okay, moving on to our next story. This is of the exoplanet Kepler-13b. This particular system is a muddled mess. And the reason it's a muddled mess is it's a tight binary system, including two stars, Kepler-13a and b, both capitalized. Lowercase letters are planets. Thank you for the bits. Thank you so much. I'm going to try and not cough when I'm excited. So Kepler-13a and b, capital A and B, are the two stars in this system, and it's a fairly close binary. And the Kepler spacecraft was able to determine that the combined light of these two stars dipped when there was a planetary transit. But exactly which of these two stars the planet was orbiting, Kepler wasn't able to untangle. Well, in new observations from a new instrument called Alapoke, on the Gemini North telescope down in Hawaii, they were able to finally untangle exactly what's going on. Now, this particular instrument is named after the Hawaiian word for fox, and just like a fox is considered to be highly intelligent in seeking things out, this instrument was highly intelligent in seeking things out. The team's analysis of the data of these two stars required them to do high-speed imaging. This is what's called speckle photometry. And they were able, with this instrument, to do it in 2 colors simultaneously. Now, the reason you want to use the high-speed photometry is our atmosphere causes light to constantly get shifted about in the sky as it passes through our atmosphere. The faster you can do the imaging, the more you can eliminate that atmospheric motion from your scientific results. And by using this technique, they were able to finally figure out that this particular planet, not going to die, they were able to finally figure out that this particular planet is orbiting Kepler-A. So this is just a cool result that starts to get us better understandings of how worlds like, well, Star Wars' Tatooine can actually exist out in the real universe. Now, Kepler-AB, or in this case, it would be eventually named Kepler-13a, or rather Kepler-13. Okay, gonna make it. So in this particular system, you have Kepler-13 capital A is the star, and now we know that the planet is Kepler-13 capital A lowercase b. Got it. And this system, 2,000 light years away, we're not seeing something that looks like Tatooine. That capital A lowercase b planet is actually a gas giant. Those are easy to see. But this is the kind of system that can potentially have rocky worlds that evolve into Tatooines. So there you have it. We know they're out there, and we now know how to disentangle their complex light. All right. In our next and final story, thank you so much for the bits, person who I can't see from here. I'm going to rotate the camera to take questions after this is all over so I can walk back over to my computer and see all of these things. It was just going to be too hard to set up quickly. So I'm reading my notes on my phone right now. All right. In our final story of the day, do you want volcanoes? You can have volcanoes. In another case of theory proven, it appears to be reality, we have the case of a rocky exosolar moon that appears to be orbiting a planet 550 light years away, potentially has a case of volcanism. So 10 years ago, researchers at Virginia calculated that when you have a 3-body problem involving a star, a close-in giant planet, so this is an exomoon, a hot Jupiter that is bigger than the actual Jupiter, you can actually still have a stable moon as long as energy is getting radiated away through tidal forces. 3-body problems are complicated. There's only one straightforward solution for a 3-body problem, and this is in the rare case of having the exact right mass ratios where you can treat one of the 2 sets of objects as a single object. So you have 2 objects orbiting one another and then a third object that orbits those 2. That's the only numerically easily solved 3-body problem. And in the case of having a tiny moon, a giant planet, and an even larger star, well, things can get really hairy. And it appears that you can prevent that moon from getting dynamically thrown out of the system with tidal forces. Now, these same kinds of tidal forces are to a much lesser degree at play with the moon Io orbiting Jupiter. In this case, the tidal forces aren't coming from the dynamics of a star, a planet, and a moon, but rather it's coming from a moon. The sun really doesn't play a role here, and the effects of other moons torquing Io as it orbits Jupiter. Here, we're going to have a much more dramatic setup and much more dramatic volcanism. And this appears to be what's going on in the system WASP-49b. And the sodium that you would expect if this much volcanism was taking place appears to be present in this system. So here's a toast to, or I don't have anything to toast. Here's a kudos to all those theoreticians that decades ago were looking at what should be present in the atmospheres of these hot Jupiters that we were just starting to discover and made predictions that we're now finally able to observe and prove true. Here's a kudos to all the scientists that looked at the dynamics of, can you have a moon when your hot Jupiter is snuggled that close to a star, and figured out the dynamics that are now proving true. This is so much better than all the poor folks that tried to predict how planetary systems are formed that ALMA is now systematically proving wrong. So here's to you. You are awesome theorists who figured out all of the things behind today's stories. Now I am about to switch over to the other side of the room so that, well, I can see all of your stuff that I can't currently see from over here. Wow, my screen is so far away. But before I transition over there, I just wanted to say, this has been the Daily Space. I'm now going to answer your questions. Please type them in and at CosmoQuestX so I can find them in the chat. I'm today's host, Dr. Pamela Gay, and I am not the only host of this station. On Wednesdays, Annie Wilson brings you updates on the news, and periodically throughout the week, you will catch either one of us bringing you all sorts of random content ranging from spacecraft launches to landings to news releases to sometimes we just, well, work while hanging out with you here on Twitch. So give this station a follow and we will work to constantly fill your brains with science. And it's normally not as big a technological cluster as we're having today. So thank you all for your patience. Thank you so much. This is a production of the Planetary Science Institute. We are a 501c3 nonprofit dedicated to the exploration of this solar system and beyond. And the Daily Space is going to be released later today as a, well, much less chaotic audio recording that you will be able to find on any of your favorite podcatchers. So stay tuned. More science in a less chaotic format will be coming. That's it. I'm going to switch views momentarily and move to the other side of the room. Hold on. I will be right back. Hello. I'm sorry for the poor audio quality here. I'm coming to you from my desk so that I can better see your questions to better give them an answer. Thank you all so much for your patience today. I am now looking up through the questions. Or through the chat, scrolling all the way up to the top. Yeah, don't get a really bad head cold. Just don't do it. Avoid the head cold. Thank you. I need too many screens. Recent events. Give me recent events. It's not giving me the recent events. Thank you, JB McCool. Thank you so much. Thank you. Okay, going back to the chat. So scanning. I saw a bad panda bear this weekend. I just wanted to say that. I also saw Steampunk Zuli and other members of our community, and it was awesome. I'm totally wearing yoga pants today, Susie. Totally wearing yoga pants. Yeah, I totally have con cred. I'm hoping it will die quickly. I hadn't done any talking this morning yet, because my husband was already at work when, by which I mean he was in a different room of our house when I got up. So I had no idea that talking was going to make me cough. Thank you, Rosaria Rose, for your Twitch Prime sub 2 months in a row. Thank you so much. Roria Rose. Thank you so much. Yeah, the con cred is still not gone. I love the never enough coffee emote, Paranor. I need to know where you got that. Yeah, Mike Cassidy. So I record from my basement, which you're now seeing far more of. So there is the green screen I have set up. You can see the random TV. No one's had the guts to carry up the stairs yet. Dehumidifier. There's my camera setup. There is some of the workbenches I've set up down here to do art. So the nearest sink with water I'm willing to drink is upstairs on the exact opposite side of the house. Okay, so yeah, I wish. Mistakes were made. So many mistakes were made. I am getting better at the muting and unmuting. Thank you everyone for noticing. I'm trying really hard. Thanks for the follow, Human Horse. Kepler-1066, thanks for the bits. I love how Larry very quickly calculated his age on the planet with a 53-day orbit. That is, or 50-something day orbit. That is awesome. Scrolling. Yeah, Falco Online. Yes. Sometimes you have the right instrument, sometimes you don't, and it turns out eyeballs from that desk behind are not capable of reading messages on this screen right here, which is why I've been using my iPad. Mistakes were made. Yes, bits are needed to feed Susie and Annie. Susie and Annie I can only pay them because of you. So please please, if you can, donate that we might feed Susie and Annie. Thank you, Wayne Johnson, for the bits, and that is the happiest cupcake ever. Looking to see what that was, and why don't the alerts show up? I have no clue why the alerts didn't show up. That makes me very sad. Thank you, Trekker Kev, for the bits. Thank you. Oh, Wayne Johnson, that is amazing. So Wayne commented that today I went to the UK High Down rocket test site on the Isle of Wight and shared some links. And I like DPI's comment that high down is the opposite of low up. I need to know more as well. I do. Looking for questions. So for those of you asking about Bennu, you may have noticed that if you go over to Bennu right now, it comes up with a password protection. We're currently in the process of having the team scientists go through, do some data validation checks, and when they're done doing that, we're going to be reopening the site with the first set of images you're going to get are those images that were presented to 15 different people, and those 15 people looked at them and clicked image done without submitting any marks and just noped hard out of them. So we're going to be doing that. And then the images that just seem to have really crappy data, we're going to be giving back to you. Sometimes we get unlucky and those 15 people we give an image to aren't the best. So Perps is asking, is the JWST still scheduled to launch in 2021 or sooner? Last I heard it was scheduled for March 2021. Let me double check that. Sorry for the coughing. Yes, it's currently scheduled for March 30th, 2021. I believe that particular date is chosen in part to say that they launched during Q1 of 2021. I don't think they're going to shift a date that is that far off in the future unless something truly catastrophic happens. Looking for more questions. Annie is just as cool in person as she seems online. It is entirely true. The whole group of us really enjoyed getting to be together in Tucson last week. In general, Susie is in Atlanta. I'm in Edwardsville, Illinois, which is close to St. Louis, Missouri. And Annie is up in the hinter regions of Ohio. So, yeah. Thank you, JB McCool, for the 100 bits plus 10 with Subway. I have mixed emotions about Subway, but no mixed emotions about bits. Zizink is saying, hey, love the show. Have you considered changing the music to something a little more spacey? Yes, we are actually in the process of doing just that. I don't have the mix with me. It's on my other computer. Stay tuned. We're going to be doing an intro to the show that it has a much more epic feel. I'm doing initial music now, and then I'm going to get something custom composed once I know exactly what the timings are that we need. Yeah, so we started out with 1950s spacey with the happy bouncy thing. Thinking much more Lost in Space type stuff. We will see. We will see. It was good to see you, Bad Panda Bear. I'm glad you didn't get con cred. You are so lucky. I always get con cred. Okay, I think I have caught up. Oh, Planetary Pan, thank you so much for resubbing with Twitch Prime. I'm sorry that it didn't give us a notification. Sometimes the software is evil. Sometimes it is evil. Yeah, Zizing, we didn't know it was going to be so painful when we did it. When we first did it, we were like, oh, that's adorable. And it does get kind of wearing on the nerves. I'm so annoyed that I don't think I have what we're doing here. Let me see if I can find, yeah, I can't. So you're just going to have to listen to our podcast coming out much later today. Looking. Falco, I love your pun on bits. That is kind of amazing. That is kind of amazing. There are indeed 10 ways to feel about bits. All right. I am now going to go get something to drink. I think it may only be September, but I think my hot tea kettle is going to get broken out and begin its season a bit early. I think I'm going to bring it down here to the basement to live with me down here. I am going to be working on putting together the editorial touches and writing up the finalized script, which should have already been done but was not, for today's podcast. Follow us on social media, CosmoQuest X, pretty much everywhere. And you will get the link when we are live in iTunes, Google Play, and all your other favorite podcast directories. Once again, I am your host, Dr. Pamela Gay, and I am here to put science in your brain. I also have con cred, so I sound kind of terrible today. Sorry. We are a production of the Planetary Science Institute. This channel is hosted by both myself and Annie Wilson, and we bring you content Sunday through Friday at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. All of our content is produced by the ever amazing Susie Murph, who runs herd over Annie and I, and we need it. And we are brought to you by you. Your bits, your subs, your patronage over at patreon.com/CosmoQuestX is what allows us to keep this show going. If you haven't already, please consider becoming our patron on Patreon. This is the best way you can support us, and it is the best way we can get you stuff to go with your content. So check it out, patreon.com/CosmoQuestX. If you can't support us financially, we totally get it. Please just spread the word. You never know whose life you might be changing by introducing them to astronomy. So that's it for today. I am going to run the credits. Thank you so much, Wayne Johnson. Thank you so much. I am going to roll the credits and go get some hot tea. I think that's really what I need to do. Go get some hot tea. So wherever you are in the world, have a fabulous morning, evening, or afternoon. Get outside and look up. And remember, we all share the same sky. Bye-bye.